All right, so let's keep working on finding zeros of quadratic functions in a multitude of ways. So we're gonna do some factoring, we're gonna do some through utilizing the quadratic equation. Let's start with the first example. I think this one, at least when I look at it, looks pretty easy to do when we factor. So let's simplify this expression. I think, let's go with the AC method, per usual, if you can see it right away. So A times C is -4, and on the bottom we have 3. So I think our numbers will be 1, or -1, and 4, right? They will add up to 3, and they will multiply to -4. So let's rewrite it, our expression, by making it and make it equal to 0 at the same time. So we got x squared minus 1x plus 4x minus 4. Then we can start factoring by grouping. And from the first one, we can only factor out x. And we're gonna be left with x minus 1. And I think from the second one, we can factor out +4, and we also going to be left with x minus 1. So it seems that we have a product of x minus 1 times x plus, well, 4. That's what I meant, x plus 4. So x has to be either 1, and the other one would be, we don't need the parentheses here, x equal to -4. Because in order for this to be true, either of these has to be 0. Okay, we can move on to the second example. Let's see. I think this one is also going to be fairly simple by using factoring. So once again, AC method, 1 times 7 is 7, and then our B term is 8. So I think 1 and +7 will do just fine. 1 plus 7 is 8, 1 times 7 is 7, checks out. Let's rewrite our function and make it equal to 0 at the same time. X squared plus 1x plus 7x plus 7. Perfect. We can group now. Okay, so from the first one, let's factor out x, and we are left with x plus 1. From the second one, let's factor out +7, and we are left with x plus 1. So it seems that we are left with x plus 1 and x plus 7. So our two zeros will be x equal to -1 and x equal to -7. Well, that actually went by really quickly, and I'm surprised how fast we could utilize the AC method of factoring to get the answer. Normally, I would just go with the quadratic formula just because this is something I like more. But as you can tell, factoring to find zeros is also pretty convenient, especially when you are working with simple numbers. Speaking of quadratic formula, why don't we try it in example number 3? So this is our A, this is our B, and this is our C. So once again, quadratic formula is x1, 2 equal to big fraction, -b plus minus square root of b squared minus 4 times a times c divided by 2a. And now let's just start plugging things in. So x1, 2 will be equal to -b, so negative times negative is +5, plus minus square root of -5 squared is 25, and then we have minus 4 times a times 2 times -25. So that's good. It's good that we have a negative number, because otherwise we would end up with a negative number underneath the radical, and we know that it's going to create an imaginary number. And on the bottom we have 2a, 2 times 2 is 4. All right, so let's get rid of, or let's calculate everything underneath the radical. So x1 comma 2 is equal to 5 plus, and let's see, we have 2 times 25, that's negative 50, times 4, that's positive 200. So underneath the radical we have 225, and obviously divided by 4. So let's see if you guys remember what is a square root of 25. I'm going to give you a hint here on the side in blue. It's 15. And if you're struggling to calculate it, you can always do it on the side. You can separate it into 15 times 10, that's 150, plus 15 times 5, that's 10 times 5, that's 50, plus 5 plus 5, that's 75. So it's 150 plus 75, 225, it checks out. So our final solutions of x1 comma 2 is 5 plus minus 15 over 4. So that would be 20 over 4, that would be 5. And the other one would be 5 minus 15, that's negative 10 over 4. That's 10 over 4, that's 5 over 2, negative 5 over 2. Okay, so it wasn't so bad using quadratic formula. Now, what do you propose for the example number 4? I think let's just keep working on quadratic formula. So I'm not going to copy the formula. I'm just going to start plugging things in for x1 comma 2. So actually, let me label what is a. So a is 1 in this case. That's our b term, and that's our c term. Big fraction divided by 2a, that's just 2. Negative b is negative 8, plus minus big square root. 8 times 8, or 8 squared, is 64, minus 4 times 1 times negative 20. Let's start by figuring out what's underneath the radical. So x1 comma 2 is equal to, we can just copy the rest, negative 8 plus minus, obviously divided by 2a. And then we have 64. And then let's figure out what this entire expression is. So we got negative 4 times 1, that's negative 4, times negative 20. It seems that it's positive 80. So positive 80 plus 64 is 144. And luckily for us, that number is equal to 12. So x1 comma 2 is equal to negative 8 plus minus 12 divided by 2. So our x's are equal to negative 8 plus 12, that's positive 4 divided by 2, that's 2. And then we have negative 20, right? 8 minus 12 is negative 20 divided by 2, that's negative 10. Done. So two things I want to mention when working with quadratic formula. You notice that a lot of times you're going to end up with a big number underneath the radical. In your class, and in majority of the problems that you're going to work with, that number is going to be a square. So I highly encourage you to learn all of the squares up to, let's say, 20 or 25. It's going to help you a lot when it comes to the speed of you solving problems. And if for some reason you're struggling and you're unsure if it's 15, if it's 16, do this calculation on the side. Split it up into, 2, 3, 4 different calculations, and that way you won't be, struggling so much to figure out what it is. Obviously, you can also do this 15 times 15, and you'll also end up with 225. Hopefully all of you still remember how to use this. Personally, I like this one, splitting things into smaller operations. I guess that's how my mind works. But once again, I'm going to leave it up to you on which way you want to utilize. Okay, let's move on to example number 5. And before we decide if we want to go with the quadratic equation or the quadratic formula, or if we want to factor out, let's actually factor out -2 from both, because this one is divisible by 2. So I'm going to say -2, and then let's see what we are left with. 2x squared plus x minus 6. Interesting. This seems like we could do some factoring. Or could we? So to be honest with you, only the expression in the parentheses has to be equal to 0. But for some reason, I am struggling to find a way to factor it out, because I'm quietly going through all of the factors of -12 that will add up to 1. And I can't come up with such. So let's use quadratic formula once again. x1 comma 2. And if you see it, if you see something that you can factor, go for it. As of right now, I'm not able to see it. Like I told you before, I really suck at factoring. So I'm just going to go with the quadratic formula. That's -b plus minus square root of b squared minus 4ac divided by 2a. So let's switch to black and start plugging things in. So once again, we are only going to consider what's inside the parentheses. So a, b is equal to +1 and c is -6. So obviously that was 0. So x1 comma 2 will be -b. That's -1 plus minus big square root. B squared is still 1 minus 4 times 2 times -6. So 12, well, let me actually not start. And then we have divided by 4, because 2a is 2 times 2, which is 4. Okay, let's figure out the number underneath the radical. -1 plus minus, that stays the same. And underneath the radical, we have 4 times 2 is 8 times -6. That's 48, right? Or you can do it like this. 6 times 2 is -12 times -4 is 48. So we have 1 plus 48, which is 49, but let's not skip any steps. And we have -1 plus minus, so square root of 49 is 7 divided by 4. So we're going to have 6 divided by 4, that's 3/2. That's the positive one. And then the second one is -1 minus 7, that's -8 divided by 4, that's -2. Okay. Once again, quadratic equation, quadratic formula. I don't know why I keep using equation. Helped us out a lot. So why don't we use it one more time, unless you are able to factor this one out. This one I think is easily factorable, so let's try the AC method. 1 times -2 is -2. Our b term is -1. So I think we can go with -2 and 1, right? 1 minus negative 2 is negative 1, negative 2 times 1 is negative 2. Perfect. So let's make our function equal to 0 and rewrite our negative x in terms of positive 1 and negative 2. So x squared plus 1 x minus 2x minus 2. And we're gonna end up with two groups per usual. So let me not forget our imaginary parentheses. And let's start factoring out. So from the first parentheses, we can only factor out x, and we are left with x plus 1. From the second parentheses, I think we can factor out negative 2, and we are left with also x plus 1. So we have x plus 1 times x minus 2. Therefore, our x's are equal to negative 1 and x equal to 2. And we are done. So that wasn't too bad. 6 examples. Some of them were completed by utilizing factorization or factoring for simplicity, and other ones are easier to deal with when you are using the quadratic formula. So be sure to be comfortable, or make sure to be comfortable with both, because sometimes you don't want to waste a lot of time doing calculations like these right here, right? For example, in the example number 6, it would be a waste of time to use the quadratic equation when you can factor out a simple quadratic expression into 2 components and basically solve for 2 x's. On the other hand, when you are not able to find factors quickly and easily, like in the example number 4, resort to using the quadratic formula and you'll be good to go.